Welcome to the Spark and the Forge podcast. I am Subrata Kar. I came across Jepson Taylor's work recently. He is the CEO of VEOX, a company building AI systems that autonomously invent algorithms. And something about his perspective really fascinated me. They are seeing fraud detection algorithms running in financial institutions working 2 to 4 times better than what data science teams design. 60% fewer false positive. And here is what caught my attention. The algorithms weren't designed by data scientists using AI as a tool. They were invented by AI autonomously. And that intrigued me. How does that actually work? What changes when AI becomes the inventor instead of the tool? And to understand this, I needed to go back to 2017. Researchers at Google published a paper called Attention is All You Need, the transformer architecture. And before that, AI processed text one word at a time, forgetting what came earlier. The cat sat on a wall. By the time you got to wall, you would have forgotten the cat. The transformer changed everything. AI could suddenly see the entire sentence at once. Every word connects to every other word simultaneously, and this unlocked parallelization. Training that took weeks now takes hours, and scaling, the bigger the model, the smarter it got. And that is why we have ChatGPT, Claude, all the modern AI tools. Everything today is built on 2017 insight. So here is the pattern that I noticed. That was 8 years ago. Since then, just got bigger. GPT-2 became GPT-3, became GPT-4, more data, more compute, but same architecture. So why haven't we invented the next transformer? Jepson's perspective, it is not the technology, it is us. Human cognitive limits, experiential bias, our ideas confined to what we have seen work, finite knowledge. We can't synthesize across all domains like AI can. Slow validation, we test 1 to 2 algorithms ideas per day. Idea scarcity, we run out of novel thoughts. His view is that we might be at a point where humans can't keep pace with what AI could do inventing algorithms itself. And which brings me to those algorithms they are deploying. So if AI is autonomously inventing algorithms that outperforms human designs in financial institutions, oil and gas, telecom and others, then something fundamentally is shifting. The bottleneck isn't technology anymore. It is our ability to work with solutions that we don't design and we can't even fully explain. And here is the part that made me want this conversation. There is supposedly a 12 to 18 months window where companies that understand the shift can build real advantage. So that is what we are exploring today. How does this actually work in production? What does it mean for how teams operate? What becomes possible that wasn't before? Jepson's company VEOX has these systems deployed in financial institutions, energy companies, telecom, and many others, and he's seeing what works at scale and what doesn't. I want to understand the mechanics, how this actually operates when you move from theory to production. And now, following is my conversation with Jepson Taylor. I want to start something, that you said in your VEOX promo. And you said, we have built the system that builds the system. Unfound algorithms surround us. Humans have only been missing the key. Can you explain what you mean?
There's a great analogy here, and that is in the world of hacking. So if I need to guess your password, I find your password. Well, I can if I randomly guess it, but it's very compute intensive. But if I can use a dictionary attack, so let's say you have a poor password, it's not password 123, but it's something a little bit more clever, your name, something else. I can still find your password. And so just like the key to the future, we think of it being the same way. So with a new algorithm or with a new breakthrough, it's discovering the combination and then verifying it. So verifying it is a big deal. So if you invent some random innovation, is it good? Is it bad? You don't know until you verify it. So I very much see the future of innovation being keys to the future. How quickly can we find keys that humans have not found, and how quickly can we test them? And then more importantly, how can we react to that traction? So I can, but all of this can be you can build systems around this. And that's what we talk about when we talk about engineered intelligence. We can build systems that will reliably produce innovation.
Sure. So let's unpack that slowly. So AI now can autonomously invent. So here is the claim that hooked me when I was reading your article and you're going through your presentation. You said humans are constrained by the limited knowledge, idea generation, validation time, and experiential bias. In contrast, AI can operate without these bottlenecks, making it impossible for humans to keep pace. That's a strong word, impossible for humans to keep pace. Walk me through that. What was that core constraint?
So it's interesting because humans have ego. So I've spent my entire career inventing algorithms. So for your audience, I've got 14 US patents focused around AI and algorithms. I worked as a quant. I've been a chief data scientist for a Sequoia Capital company and named HireView. And at the time, I managed my team. Everyone on my team had a PhD in physics. And one member of the team was top 60 in the world globally on Kaggle. They're really smart people. And so in my career, I've worked with data scientists that are paid $1 million a year. So I understand what that talent looks like. And a lot of times we depend on that talent breaking through the wall. And what I've realized over time is the human approach is, it's very clumsy. And I'll go into a little bit more detail. So I think some people think of innovation as a stack of Legos that we're filling in all the gaps and we're building into the future. But now I see it as a system of sparse roots. What's the likelihood that humans missed a profound mathematical breakthrough? Well, it's 100%. That's the way I see it now. And so a point for your listeners, if you and I, let's say right now after this call, and I don't know if you have a PhD. I don't have a PhD, but if we decided to get a yeah, I don't. So if you and I decided right now, we're going to go get a PhD in computer science right now, and we're going to invent something profound in AI, an XGBoost alternative, a Tab PFN alternative, or the next LM architecture, I would say right now that would be nearly impossible for either of us. And it's not a matter of intelligence. If we backed up 20 years ago, I would say it's guaranteed. 20 years ago, if you went to school, guaranteed you would find a profound breakthrough that was meaningful, and I would as well. So what's the difference? Humans are running out of ideas. And that's pretty clear. And so that's where I see these systems breaking through our bias. And I can explain this a little bit more clearly. There's 4 key pillars. So the first pillar is humans cannot consume as much knowledge. So everyone agrees. You can't read every algorithm in the world. You can't read every book, but these systems can. And then humans are limited by ideas. So assume you and I are in school and we are working with our advisor. We're trying to come up with some big ideas. Can you come up with 1 million ideas? You can't. Maybe you'll come up with 2, 3, 4, or 5. And then how do you validate those ideas? That's the third pillar. So the human ability to validate ideas is prone to error, and it takes too long. That's the whole hero's journey. you'll spend 7 years testing your ideas, reacting, some are good, some fail. And to every algorithm researcher out there, they've often had a eureka moment that ends in disappointment a few months later. They think they found a big breakthrough and they did not. And then the fourth one, this is the controversial point. Humans are trapped by their experiential bias. So even the polymaths, even the ultra creatives, the people like Elon Musk, they are trapped by their experience. They physically can't have an alien idea. And we believe these systems are capable of escaping their training bias. So they can actually, and this is where people will argue. So the fourth one is the most debatable, that can these systems escape their own bias? And I think they can. And I think we're seeing evidence of that.
So you're saying we are moving to a space where human wouldn't explore, but AI would?
It changes the role of the human. So if you think about the pipeline of innovation, you've always depended on the human being the builder. Going back to that $1 million a year data scientist, they're building these systems in the middle, and the activity is going to change. It's going to go to the beginning. What are the questions you're asking? What are the quality of those questions? And then how do you judge success? And judging success is actually much more complicated than people realize. So if I invent 2 new algorithms, and let's say they have a higher accuracy, if one of them has a faster training time or a faster inference time, you're now going to have a different opinion. Does that make sense? So if I can begin throwing algorithms at you, your judgment is going to become much more complicated. What do you want? What are you looking for? What's the priority?
For the benefit of everyone, just explain, when you say algorithms, what exactly do you mean?
So algorithms can be many different things. So think of binary classification, regression, time series, LLM alternatives. But an algorithm can even be a prompt. So if I have a prompt that's going to go into a system, that prompt itself is an algorithm. That can be, but you could even say a chemical, anything that can be represented by text. So even some material science compound or some biological asset. I would also see
the seed inspiration.
Yeah, so inspiration seeds are funny. I'll give you a few examples. So because these systems can autonomously build algorithms, they have to seed the idea. So the initial spark of an idea, I'll give you an example.
Yeah.
So and your users can test this. So if you go into OpenAI Pro, if you go into Gemini, and if you begin working on a very clever prompt, and if you say, I need to invent a new algorithm, please don't write the whole thing from scratch. Please don't use anything existing. And I need this to be competitive against XGBoost or pick a category. Now you're going to give it an inspiration seed. I am inspired by the hunting behavior of sharks. They follow levee distributions, they swim long distances, and then they'll do rapid hunting. Please use everything in your knowledge base to inspire the next big breakthrough. That would be considered a seed. But the funny thing about inspiration seeds is, if I say something like that, that sounds sophisticated. But if I say something like, you're in the matrix, close your eyes, you woke up, you're in the white room, something floats out of the floor, it's something that humans have never seen, something that must come from aliens, which of those inspiration seeds is better? The first one I gave you, kind of algorithm researchers will agree that there's some sensical path. The second one is nonsensical. But both of those will build algorithms. And the funny thing is the second one yields better results than the first. And so ultimately it comes down to judgment. So how quickly can you build an algorithm? And for the approach I gave you, that is not a very efficient approach. That feels more like gambling. So if you make that call thousands of times, eventually you might get lucky. And that's where we've focused on engineering the luck. And I can go a little bit more deeper into how we do that.
Right.
But yeah, your users could get lucky just following what I mentioned. They might find something that is interesting.
Let's go back to 2016. AlphaGo played Move 37 against Lee Sedol. Thousands of years go practice and never play there. Every expert watching called it kind of a mistake, but AI made that move anyway, and it won the game.
So I love that example you gave. And I forget, it was game 2, Move 37. And the critics laughed. The critics actually criticized it and they laughed at the move because they thought it was a mistake. Yeah. And then later they realized it was an alien move. So it was an alien idea, but I can explain where the idea came from. So within deep learning, my last company was a deep learning company. So I was the technical founder. I have a pretty good grasp on deep learning. And within deep learning, you're building, at the time we used to call them topics. So I'll give you a quick example and then I'll bring it back to AlphaGo. So we trained a deep learning model on scrapbook photos for a customer. So if I look at your camera roll, can I predict if one of your photos is going to end up in a scrapbook? And so if you think of ImageNet, you have these models that are pre-trained. And by training on that data, we found a new topic. So a topic that naturally came out of the data was the concept of a sleeping baby. So if you have kids, or if anyone has kids, you really like the photos of them sleeping. During the day, you're surviving as a parent, and oh, this little monster's asleep. How adorable. And you take a photo. And so the concept of a sleeping baby was learned from the deep learning algorithm, and we would consider that a topic. And so going back to Go, when you have huge deep learning models that are learning from game experience, they will form knowledge clusters. And so that move in AlphaGo, it was not random. There were knowledge clusters within the gaming system where it understood that move had competitive advantage. It's not just randomly asserting that move, but a human, our brains don't have the complexity to suggest something like that. But I love that example you gave, because I would refer to that as an alien move. That's not what humans would have come up with 10 years from now. And we see lots of that now in the LLM space with agents. We see alien moves.
We went back to 2016, but 2017 is an interesting time. Google published the paper called All You Need Is Attention. And of course, we have this transformer in 2017. It was profound. And you said after that, there hasn't been any great invention.
Not at the core, not at kind of the mathematical level. So
why couldn't we do it again?
Because humans have hit a wall. So to that example of you and I getting a degree in computer science right now, I would say it'd be physically impossible it'd be virtually impossible for us to find a mathematical breakthrough. And on that point, how many humans, the Attention Is All You Need paper was such a big deal. All those authors were very successful. They all went on to, they're offered unbelievable amounts of money for their own startups. Right. How many humans do you think have tried since then to come up with the next transformer? I would argue thousands. Like, so many humans have tried because they know if they can find this will be a big deal. And I would say they've all failed. And so the huge breakthroughs since Attention Is All You Need have been more on the engineering side. So to be able to train
despite the fact that we now have all this compute, we have this other enablers to help us progress, we haven't seen that kind of algorithmic invention.
Well, and there's another important point. I heard someone say, I really like this point, that all of the beautiful things that you and I appreciate with AI today, GPT and LLMs, someone made the point that they were always available to us, but without the transformer, it would require 1,000 times more compute. So they're not feasible. And so really the innovation there is around compute efficiency. And that's what we're going to continue to see going forward. It's all going to be about compute efficiency, because if I can make my cluster feel like I have 1,000 more GPUs than you because of some mathematical innovation, that is a huge advantage.
So I understand there are listeners in this who are investors or tech founders. So if this is the new reality, Jepson, that AI can now explore um, new ideas, space that we can't even imagine. What does that mean for founders and investors trying to stay competitive? What
Well,
patterns are you seeing, and who's winning in this intellectual battle?
so the number one theme going into 2026 and 27 is adaptability.
Mm-hmm.
And that's in line with how we think about the world. And so if you have, I now see human algorithms being expired, like rotten milk. And this is a problem on two fronts. So if you are a founder, if you're an investor, you have budget to hire a data science team. Are you going to hire expensive data scientists, the $1 million a year plus data scientists? Or are you going to hire junior data scientists, $150,000 a year? What are you paying for? You're paying for their algorithm knowledge, which is quite limited. And in this new world, we can invent more algorithms in an hour than humans have in history. And so in the world of being adaptable, the role of the data scientist will change. No human can compete against these new pipelines that are being built. And so why on earth would you have a human using outdated, clumsy approaches where it doesn't mean they go away, but your human should instead be focused on the questions that are asked and the quality, the judgment layer. And so it's all about adaptability. How quickly and then we also see it as a data maximization. If you want to maximize the value from your data assets, you can only do that with these new techniques.
I understand that there is a competitive gap opening, and you made a personal bet on this. You could have stayed back at Data Robot after acquisition, safe, predictable, but instead you started VEOX to solve this problem. So when you started, what honestly did you think the chance of success? And what did you see that made you willing to take this risk anyway?
So this is more of I love that you asked this question. So VEOX is my third startup, and anyone who's done a startup before, they're terrible. You don't want to do a startup. And when I resigned from Data Robot, and when I actually went and joined Data IQ after, and during that period when I was deciding what to do next, I had some investors telling me that if I go do another startup, that they'll invest. But to do a startup, my recommendation is you need to have that idea that's burning a hole in your head. You need to have that idea that's keeping you up all night, and you need to have that idea that is so big you're willing to fail. And then I define failure, and that scares people. So I like talking to college students because their brains are like Play-Doh, and they've been kind of taught through this very rigid system. So if I'm talking to college students, I'll say, I hope you do a startup, but you need to have an idea that's so big you're willing to fail. And then I'll define failure. Failure is your net worth goes to zero, you max out all your credit cards, everyone's calling you an idiot. Like you have to beg friends and family for favors. And when you say that, people get scared. And then I go back to the idea and I say, if you're scared, the idea was not big enough for you. Who cares what your professors think? Who cares what your friends think? Who cares what your parents think? The idea wasn't big enough for you. And so this idea of autonomous innovation has been an obsession of mine for 10 years. So I tried it 10 years ago. I tried using genetic programming to discover novel algorithms, and I gave up after a year. It was too complicated. It wasn't working. And then it wasn't until ChatGPT came around, which I did not see coming. So even though I had a strong background in deep learning,
8 years ago, 7-8 years ago, or
I forget the exact date when. I can't recall off the top of my head the exact date when ChatGPT showed up. When ChatGPT showed up, I was at Data IQ, and it wasn't until GPT-4 level technology showed up.
It is about 3 to 4 years max.
Yeah,
possibly around that time. Okay.
And when GPT-4 level technology showed up, within a few weeks, I was able to show autonomous innovation. around a very narrow algorithm class, and that was optimizers. And that was enough for me to kind of catch that fire that I didn't know if it would be possible for more complicated algorithm categories. I didn't know if we could do this for binary classification or LLM alternatives, but it was enough for me to begin that hero's journey. And now we're to a place where I would say it absolutely generalizes. So every algorithm class the same system can be applied.
Okay, so you had this great idea, big enough for anyone to think that he might fail, but you bet on it. Let's get into the mechanics of it. So you were proving this at VEOX in production. Let's get into that mechanics. Walk me through that engine. How does AI actually invent an algorithm?
So the unique point of view, or the unique breakthrough that we had, excuse me, is we do something very different. We do something, we're calling it algorithm decomposition. So when AlphaEvolve, so Google had AlphaGo and then they had AlphaEvolve. And AlphaEvolve was able to find a profound breakthrough with matrix calculations, which humans, I think it beat a 50-year standard. But their evolutionary process, it was just using agents, and the evolution was happening within the agent space. Our approach is different. We do what's called algorithm decomposition. So we'll take an algorithm class like binary classifiers or optimizers or LM alternatives, and then we'll take all the known human attempts in that category, and then we'll have reasoning agents decompose it into a genetic soup. So with that genetic soup, we can then apply evolutionary forces to begin inventing new algorithms. And this gives us a lot of control. So there's a few things we get with that. We're not constrained by context window anymore. So we can run a very large evolutionary process with millions of algorithms, and we can comprehend the entire evolutionary state. So even someone like Google, if they're attempting to run AlphaEvolve, they can't maintain the entire history. They're going to run out of context window. And then the other breakthrough is our output context window. We're no longer limited by that. That was an issue for Google. There's a reason they're inventing the matrix multiplier. They're not inventing an LLM because that output context window is much larger. So this approach, it allows us to handle both, but it also allows us to have a lot more insight into what is driving the innovation. So when we invent a new algorithm, we're actually just inventing a certain part of a larger pipeline. Does that make sense? So we're not inventing the whole thing. We're literally targeting the innovation.
But in terms of volume, how many algorithms variations can the system generate as compared to human team, just to get an idea?
So that I see no limitation.
Million?
Yeah,
Million?
it's nearly infinite. So really from our well, this is another fun topic. Knowledge verification. So if we invent a new algorithm, how do we know that it's novel? How do I know you don't have the same thing on your laptop? And with this approach, we have proofs where we can show people that it's statistically impossible for a human to have this same algorithm. So when we decompose an algorithm into, let's say, 7 stages, and then for each stage, the volume of that stage library is increasing because we have agents that are inventing new algorithms within a stage category. And so based on the number of combinations and based on the size of the stage library, the final algorithm coming at the end, the likelihood of a human inventing that is near zero. There's no chance that a human has ever written this sequence of code before. Does that make sense? It's just a numbers game.
That's interesting. I want to go back to listening to your July presentations. I forgot which year, and you said something like AI hallucinations, typically seen as flaws in practical applications, are valuable for creativity. The paradox lies in the same mechanism being a bug in one domain and feature in another. Now, that's a bold reframe because I just did an episode on AI generated code where 45% has security vulnerabilities. The entire industry is working to eliminate the hallucinations because they break the production system. But you are saying in algorithm inventions, hallucinations are assets. Explain that paradox and how is the
Yeah.
same mechanism is bug in one place and and breakthrough in another.
So if I have an agent that's used for an airline to do customer support, a hallucination is devastating because that becomes a liability. I need a system that behaves a certain way. But if you think about the core of innovation, even from the human side, hallucinations, if you think about the discovery of penicillin or the discovery of LSD, there's a long list of discoveries that were chaotic, they were random. There was no intelligence to that discovery. But then humans had to react. And so, and this is where you'll see a lot of negativity in the AI community. So you'll hear people say an LLM is a stochastic parrot, and an LLM cannot. You'd be surprised. I'd say more than half of AI people, if you ask them the question, can an LLM generate new knowledge? They will quickly answer no. But if you press them on their defense of that, you'll realize they have no intellectual argument. And so,
So what is your argument? So what is your argument for that?
So my argument is, maybe I'll be a little bit more antagonistic right now with my response.
Sure.
So my argument is that mindset is stupid. And the reason it's stupid is, let's pick any innovation. Let's pick a profound innovation, general relativity. So let's say no human has even considered general relativity. Is it possible for me to invent general relativity? Yes, it is, by random. So if I'm randomly swapping out characters in a mathematical equation, you would understand that the vast majority of them, 99.999%, are nonsensical, they're garbage. But eventually, there's nothing stopping me from randomly guessing general relativity. And so we see this as a search problem. So just like the hacking approach, I can try to hack your password, but it's difficult. But as systems become more intelligent, the ability to guess general relativity increases. And so ultimately it comes down to the verification. So if I had an LLM that hallucinated general relativity, if I have a system that can verify that, that's all that matters. So I guess to kind of close the argument, to say that it is impossible for an LLM to generate new knowledge is a stupid perspective, because I already proved we can do it randomly. I can brute force innovation randomly, and LLMs are not random. And so, let's go back to the AlphaGo example. That A-Lane move came from somewhere. It wasn't random. The knowledge structures drove that incentive. And so, as the quality of LLMs increase, your hit rate, your search rate increases. And then the other thing that's happening too is we can benefit from the traction of all guesses. So every good guess drives the future innovation. So when we're going to invent part of an algorithm, we actually know the exact location that we're going to apply that hallucination to. So ultimately, this is just a search problem. And we already see the benefits. So the code that is coming out is performing much better than anything humans have written before, and this is only going to improve. And then the other point to add, the moment I verify new knowledge, that becomes part of my training system. So these systems just reinforce themselves. Every time I verify new knowledge, that becomes part of the foundation. And so that's why there's nothing blocking humans from continuing this search.
But there has to be some amount of validation filters when AI starts hallucinations.
Yes.
So let me. So how does it work? How do you know that you are generating millions of algorithms with higher failure rates, but you have made
So that
validation also autonomous, because you don't have humans to sit down and start validating which is really good or bad. So how does that change the economics? How do you really avoid validation wall?
so one of the things we talk about is this concept of I call it the stillborn rate. So when I invent a new algorithm, does it
Yeah.
even run? Does it even execute? In going back in time 10 years ago.
Explain that for people who didn't probably hear that word, because I read it. So
Um, so so just like having a new offspring or having a
yeah,
child, is the child going to be viable? Or
yeah.
does it have fundamental defects where it won't even run? And that is an important part of your search, because if the majority of your algorithms that are being produced are stillborn, meaning they have fundamental flaws, they don't even run, and an agent is unable to repair them, then there's no value to that cycle. And so that's one of the things that we've spent a lot of time on. Our stillborn rates are incredibly low. So
Mm-hmm.
so the algorithms we invent are viable, and then they're immediately verified. And based on the good ideas, they will drive future guesses. So so designing systems that minimize your stillborn rate, that is a key part in this process.
All
But
right.
our stillborn rates are lower because
When you say lower, what range we talking about?
they're near zero. So I would say our stillborn rates are probably less than 3% on
So
new
now, if
algorithms, right?
I know we're talking about algorithms. Now, if you look at the coding part, right? So developers today generate codes, then they use AI tools to validate. Even if they do all of that, is still 19%, 20% slower rate. But you're talking about and keeping the human in the loop, and you're talking about doing this millions of algorithms, and you probably have a near zero failure rate, which means you may be talking, let's say 1%. So you're running the validation also through agents on that 1%.
Um, so half of what we do is benchmarking. So we have distributed benchmarking. So we have a reasoning agent working with a scheduler. So a reasoning agent, the scheduler will request new innovation on a particular stage within a
All of
particular
these are
algorithm.
fully autonomous. There is no human
Yeah, it's all
involved.
completely automated,
So there
which
is no
is
question of any human in the loop in this endeavor of yours.
so I can. So the short answer is no, but I'll explain where the
No.
humans are active. So the fun thing with this problem is it is an infinite problem, because the reason this is an infinite rabbit hole is there's continuous insights. So having a system that can invent new algorithms, there's always ways to improve that system. I can
Mhm.
improve that system with its compute efficiency. I can improve that system with every new algorithm we build, we have to analyze it. Because if the algorithm that is being built is too similar to something from the past, that's not a value add. And this is hard to communicate to the listener, but I'll do my best. And
Yeah.
so really, we are searching an idea space. So for every algorithm that's been discovered so far, I can produce a two-dimensional plot. So imagine all the human algorithms and imagine all the AI algorithms, but a lot of it is black. And the fun thing about looking at this black space, it's impossible for a human to deterministically search in the void. So if I show you this visualization,
Hmm.
most humans will get excited. They'll think, oh, that's really interesting. I can see the algorithms evolving and searching the space. But if you point into the black
Hmm.
void and you say, I'd really like to test an algorithm here,
Hmm.
it is impossible for a human to generate the inspiration seed that will go there. But we see evidence that these new systems can deterministically create an inspiration seed. So in the entire universe of ideas,
Hmm.
this then just becomes a search problem. So AI's ability to inject an idea. The other analogy is think about how human cities are. So you have big cities, and that's kind of what you see. You see these cities of ideas. And so if we throw an idea out in the desert, No human has gone there before. But if that idea has merit, then the computations will follow. And so going back to the penicillin idea, that could be an idea in the desert, but AI is going to search the desert. That's how I see this playing out. Is ultimately it's a search problem to the end. What is your ability to search the void? And humans are not, our brains are not equipped to search the void, but these systems can.
So before we talk about success story, let me also push a little bit to understand the boundary conditions of this, right? So where does this approach fail today? What kind of problems or domains does this autonomous algorithm inventions not work well for yet?
So they definitely work better where you have larger algorithm class examples. So think of something like optimization, binary classification. You have many, many human attempts. If you have an algorithm class that is very sparse, like maybe, what's a good example? Maybe you have like a bin packing problem. You have some algorithm class where humans don't have a lot of solutions.
Yeah.
You might find that is more difficult to kind of get that running. The other place it doesn't work is where validation is complicated. So we do have an algorithm category called, I think it's called physics theory, where we do have general relativity alternatives. And so we can produce alternatives to general relativity, but now the challenge is, how do you know, just because an agent is grading the solution as having really good coverage for the known universe, and it believes it has higher accuracy, validating that is now difficult. Validating a binary classifier is easy. Validating an LLM alternative is easy. But validating something in material science or something in chemistry or something in physics, that validation is not a closed loop validation yet. Eventually, it will be a closed loop validation.
I wanted to ask you the validation because you alluded to. So the economics change everything, right? Just for the sake of it. So when testing cost goes up to cents instead of thousands, so 99% failure become acceptable. Walk me through that validation layer that you talked about a little bit in a detail, so that we understand how do we really vet these algorithms.
So initially, when we started, we kind of had a price estimate on a novel algorithm. Produce a superhuman algorithm in binary classification, something that would consistently beat XGBoost. Early on, the price of discovery could be maybe around $1,000. So for you, computationally, for you to find that was $1,000. And now the price continues to drop. Where it's dropping so low, I like to say the price is essentially zero. Like it's dollars. It's falling to zero. But for other algorithm categories like general relativity, the price will remain unreasonably high, not for the idea, but for the validation. So even if you and I were physicists, I don't think it wouldn't be very difficult for me to show physicists some equations that seem profound. They have justification, but validating them, and that's also an issue with things like string theory and other alternatives. Validating them is not, it's almost not even feasible on our timeline today. We think we can validate them in the future. So general relativity, when it was discovered, Einstein was unable to validate it when he was alive. We had to witness certain events in astronomy later to validate these ideas, and so that is your bottleneck. Your bottleneck is in the validation layer. So if the validation layer is straightforward, then I would say the cost of innovation is measured in dollars. It's not thousands of dollars. Or think of the human alternative. So if you task me, the human, to invent a significant breakthrough, to invent the next transformer, that's really expensive. How many humans do you need? How long is it going to take? But these systems being autonomous, it changes that. It changes the cost structure.
You talked about some agents used to take some consensus. So if you're using agents, so you're using AI to validate AI. It's very different paradigm. So which means the multiple models voting on whether one algorithm is worth testing. How do you
So,
know they are not just
so,
sharing the same blind spots?
so when you do algorithm verification, it's being validated on outcomes and performance. So they're being trained on real data sets. They're being benchmarked on blind holdouts. If you are validating something like a general relativity alternative, then you are stuck in that trap where it's just AI grading the outcome based on some rubric. It's not. So the first one is hard math. The first one, even the data science community has to agree that these benchmarks are real. They're coming from real data. It's not some LLM's opinion. The second one is gray. An LLM is having an opinion. You don't have hard validation. Another example is, let's assume you task one of these systems to write the world's most profound poem or the most viral LinkedIn post. You could have an LLM that is coming up with some rubric, and that will evolve into the future. But you and I are still stuck with, just because it evolved to have this rubric, we actually don't know if it's the world's best poem. We actually don't know if it's the most viral LinkedIn post. But we do think it's a better than random idea, because the LLM having some type of a rubric, especially how smart they are now. Another way to think of it is, it's you, the human poet, or you, the human influencer, you, the human physicist. We're trying to get a list of short ideas in front of you that you will react to. So without these systems, you're left to your own mind. But with these systems, that might inspire you to react. So I still see value in both approaches, but that's how I would split it. Half of these are hard validation. Like, think of creating a stock trading, because we could also do trading pipelines. So having a stock trading pipeline, the Sharpe ratio or the Sortino that it's getting on new data, that is a hard benchmark. And the systems can react to that benchmark. So it's kind of fun. You have this gray validation, and then you have hard validation. A lot of algorithms have hard validation. So that protects us from the LLM opinion.
So test harnesses the anchor and the human-defined success criteria that algorithm must meet?
Yes, and this can get more complicated. So I'll give you an example where this goes wrong. So if we are inventing an LLM alternative, and let's say the fitness criteria is loss, you want the validation loss to be low. If you go to sleep and you wake up and you find out that the agent blew up your parameter space, you're not going to be very happy, because that's not a clever idea. You could have given yourself 1 trillion parameters. And so this is where the fitness criteria become very important, where now you might be more sophisticated. You want bits per token. You're going to have a max threshold. It's not allowed to have more parameters than this. And so that's going to force it to focus on architecture. And so there's a lot of effort that goes into what is the test, what is the fitness criteria, because these systems will cheat. So if they realize that they can cheat and look at the forward token or do something that is obviously cheating, they will do that if you don't have the right restrictions. Because think of it as a game. You have the test harness and you have the agent, and it's playing a game. It will cheat at the game if it's allowed to cheat. And so that's something that we've had to react to, is to ensure these test harnesses are robust. That cheating,
it could be a very catastrophic consequences, especially in a live enterprise environment.
Well,
how do you do that?
So for some algorithm classes, the validation is already well understood. So think of binary classification or like a stock model. Having a blind holdout that is never available. So even though you're evolving all of these algorithms into the future, during the evolution, they never have access to the blind holdout. So they're making evolutionary decisions based on some internal validation. They're never allowed access to the blind holdout. So that's a good way to protect ourselves to having that air gap. So they can evolve into the future, but they're never given access to the testing. And then that becomes true at the end. And so that's but a lot of that validation has already been figured out. Because of AutoML was very dangerous early on because you can fall into the same trap. So, but yeah, that is a challenge. The test harness, going back to the gaming analogy, AI will absolutely cheat if you give it an opportunity to cheat.
So I saw VEOX is reporting about 2 to 4 times increase in fraud detection, 60% fewer false positive. That's massive. And I'm curious, the specifics, what was the company's actual problem and what did AI discover that human missed? And how does the team really differently now?
So ultimately it is going to come down to the user's data set. So some data sets have tremendous lift beyond what the potential lift has already been saturated. So one of the huge advantages we have, besides the, I'll back up for a second. There's a few ways to think about this. So let's say you have a business problem. You're going to predict credit card fraud. Today, you can use the recipes that humans have provided. You can use the different AutoML, you can use AutoGluon, Tab PFN, you can use several of these. You might even develop a very sophisticated AutoML strategy, but the number of ingredients are limited. So you're trying to build a recipe, but your ingredient number is small. So we have a very large amount of ingredients. So we can build many different stages for that problem. But one of the big breakthroughs is we can actually bring a reasoning agent into the pipeline. So in that pipeline, we can actually have a reasoning agent that consumes your data. So it'll literally look at your data, it'll consume it, and then it will inject domain-specific features. So this is something your humans could have done. See a lot of lift here. And so those two things combined can give us tremendous lift on a problem where humans had hit a wall.
You talked about human because I'm curious because if these algorithms are incomprehensible to human intuition, what's the kind of new skill set the teams need to work with them?
So the algorithms that we invent, they are open source for our customers. So an algorithm that's invented for your data, it's not a black box. You can read all of the code, and we actually see that as being your IP. So before you deploy an algorithm, you can understand everything that was done. You can look at the full source code. You can understand what was of human origin, what was of AI origin, and then you can make a decision on whether or not you're going to deploy that. And this kind of fixes the hallucination issue. So the hallucinations can be used in the chaos of innovation, but the thing that is finally sent to you, it's actually a very robust algorithm that you can decide if you're going to deploy. And a fun way to think of this is, I like to say we're stealing algorithms from the future. So could a human have invented what you're looking at? Maybe, but we don't know the timeline. Going back to the AlphaGo problem, could a human have invented that move? Maybe, but we don't know the timeline. And a fun concept for your listeners, let's assume that you and I, time travel is possible. So you and I are going to go back to the 90s, and we can take one algorithm with us. Well, for me, I might take XGBoost, which is a binary classifier. I'm just going to steal that algorithm. I'm going to go back to the 90s. And if I had that algorithm in the 90s and no one else did, what is that worth? Well, it's worth everything. I could own hedge funds. I would essentially play God in the 90s. It'd be worth trillions of dollars to me if I had that algorithm in the 90s, but no one did. And so they were forced to use support vector machines, logistic regression. And so if you were in the 90s with that algorithm, it would be an unfair monopoly. And so that's how we imagine this is the algorithms you're looking at. They could have come from human origin, but it's a very simple algorithm. There's no hallucination using this algorithm. It's not going to behave. This is part of our vetting process. We need algorithms that have the criteria that you require, whether it's accuracy, being robust to outliers. You get to decide the criteria that you need for your production system.
So should we think that the skill set for human is now shifting from creator to validator and system designer?
Yes, I think you articulated it very well. There's a huge question mark on the future, and the huge question mark on the future is the future of talent. So I know great engineers and researchers that I'd hire in the past. CTOs are torn right now because do you hire a principal level engineer who's classical, or do you hire some young kid who is running 1,000,000 miles with anti-gravity, cursor, Claude code? You're kind of stuck in this weird world. And one of the issues we've always struggled with is how do you measure engineers? So I can't measure them on lines of code because they'll just write more code.
Yeah.
I can try to measure them on a sprint, but they sandbag their numbers. So they'll say this task is worth 9 points, that task is worth 7 points. And the funny thing with AI is we're moving into this meritocracy where you could be an Uber driver that I meet somewhere in the world. You have no foundation on paper, be the hire that I desperately need based on performance. And so I think a lot of people in a work culture, I can't have AI hiring and firing people because that is a bad work culture. Engineers will be stressed out. If you understand that every line of code that you're writing, AI can now assess it. And AI can tell me, how creative are you? What is your dollar per throughput? But I think you're going to see that in some settings, like a hedge fund setting. I think you're going to have a hedge fund in the next year or two where AI is hiring and firing quants in real time based on it's human plus AI, right? No one cares what you know with your keyboard. They only care what you produce with these AI systems. And so the 100x engineers.
So will you essentially will have an agent to evaluate an human? On what criteria?
So we already have assessments we can run. So if you give me access to your Git repo, this is something humans have not been able to do. I can score your entire Git repo and give you a number where it'll analyze every line of code that you've ever written. And it doesn't matter how many Git repos you have. And it's going to give you a score. And that score is meaningful. And it's a score that humans were unable to do. If I'm the reviewer, and if I have to go through and review your entire code base, I don't have time, and I also don't have the insights. And so there's another profound thing here is humans have always celebrated the T engineer. So I'm really deep, but I know I'm kind of broad. I can do front end, I can do back end, but I'm really deep on this topic. And I heard someone say that everyone's becoming a square. So with AI, you should be a square, and I'm going to measure you on being a square. And if you're not a square, then you obviously don't understand AI systems, because if you write code tonight, the moment you're done with your code, you should then begin interrogating it. What am I missing? What would a CTO find fault with? And so you could imagine if you go through a few cycles of that, what would a CTO find fault in this current code base? Eventually, you should be looking at a square. You should have a code base that's square. And when I audit it, I will find out. You have no excuse to build me a code base that is not scalable, deployable, security compliant, performant. Like, you can come up with a long list. You as the user no longer have an excuse to not provide that. You can't tell me, oh, I don't know backend, or I'm not very good at front end. That's no longer a valid excuse. That was always an excuse for the human.
Right.
So and this is scary. The reason it's scary is, I would argue, in the next 2 years, I would say 20, obviously I can be wrong because I'm projecting into the future, but the next 2 years, I would say 20 to 30% of the tech talent will be fired. And they will be fired because they were not adaptable. and they will be replaced by people that are adaptable. Because I think the competition is just, you've heard the term the 10x engineer. We've always talked about the 10x engineer, and I've met some. They're not truly 10x, but they are multiples of the other engineers. They're unbelievable hires. If you backfill them, you always have to backfill them with a few people. And we see the 10x engineer becoming the 100x engineer, becoming the 1000x engineer. And so I like to say every single year, you're going to see a 10x increase in engineering productivity. And that is scary. So do you have an engineer somewhere that can outcompete 1,000 of your people in the next 2 years? And I'd say the answer is yes. But that also has liability, because if you have an engineer building that much code, how are you going to make sure it doesn't cause problems? How are you going to make sure that it, and we're going to see a lot of problems over the next year or two with people that were overly optimistic on ambition or with agent coding.
Let's talk about market intelligence and competitive positioning, because I think we reached a point. So here's a strategic question, right? If AI can invent superior algorithm for me, it can eventually do the same for my competitor as well. Then what becomes the new defensible moat for the algorithm itself, which is no longer the key asset?
So I think you like this. The defensible moat will ultimately come down to the data asset. So you as a company, you have this data asset, but the concern is, are you maximizing the return on that data asset? Because for every ounce of value you get from the data, it's going to spur new questions. So going back to the role of the human is now split. You're not the doer. You request the hero's journey and you validate the outcomes. And so a company's ability to do that quickly will have an advantage over someone. A lot of companies globally are still stuck. They haven't even finished their data transformation. So if I'm company A, I haven't deployed a lakehouse, I'm still dealing with my data transformation. If you're company B, you're ready to go. Every new algorithm you invent is going to inspire different ideas on your data. And so even if I get access to the same technology in a year or two, you're years ahead.
Okay, let me put it. From your vantage point in VEOX, who's actually getting this? Who's winning and who's falling behind in this?
So I think with any innovation, you have companies that have a lot of red tape. They're slow to move. They don't take risks. And then you have companies that are willing to take risks. And so the companies that have the leadership where they see the writing on the wall and they're willing to take these risks, they're going to be the people that win. The companies that are more conservative, it's harder for them to onboard a technology like this. They're not going to have these systems for quite some time.
But why should a company resist when they see this huge advantage and leapfrog the gate? So who are resisting this and who's fighting the ship when you're describing it?
So one of the issues that shows up is security compliance. So if I am a machine learning platform and I'm coming into a company and you have very strict security requirements, you have to be able to audit every single open source algorithm that I'm using. And today you can do that. You will succeed. But when you have code that's exploding, from a security perspective, how are you going to audit all of that new code that agents are writing? And so that for some companies, that's going to be a gating mechanism. The security will be so resistant to, in the end, you're going to have systems. So in the end, the only way to audit that much code is you have to have agents that are auditing it. And then you have to have sandbox arenas. So when we do our algorithm benchmarking, so our core system's written in Rust. And that system it does the scheduling, it has the intelligence, it's not doing any code execution. And then we have workers that are quite stupid. And that's where they do the actual code execution. So we're designing systems that are safe from a security perspective, but if you are a very risk-adverse CISO, that might not be enough. If you're a risk averse CISO, you might panic if you realize you have millions of algorithms that are being created by AI that could be executed. And so you might have to, so some companies, they get it, they understand it, they'll lean into innovation. Other companies, they...
Okay, so which kind of category of companies? Is it $1 billion plus company? Is it a small mid-segment company, less than $1 billion, or pockets of pockets of areas or use cases where more acceptable?
So our focus, we're focusing on larger companies where a single AI win can justify our SaaS license. So if you are, it's interesting. Talking to a lot of different companies, let's say you give me a particular problem. So you have this data set, you're already using it to predict fraud, you're already using it to predict some type of chemical process. And if I ask you, does a 5% increase on this problem have a meaningful impact on your business? A lot of people don't know the answer to that, and they are the wrong partners. Some people know the answer to that. Some people say, well, for this particular problem, it's worth hundreds of millions of dollars. And those are the people that we're chasing. Because in industry, telco, oil and gas, banking, energy, there's larger companies that those numbers are easy. And that's what we saw at DataRobot is with DataRobot coming in, we don't want to sell to a company where improvements are not understood. Because a lot of companies' improvements are, if I give you a 5% better model, you don't have an answer for me. And that's not a good partner.
So before DataRobot, you founded Zeph.ai?
Yeah, so that was a deep learning platform.
And that got acquired by DataRobot, right?
Yeah.
So when that deal closed, what signal did it send? Did that validate your thesis about autonomous generation for the wider market? Or?
So selling companies is funny. Most founders that you talk to that sold a company, it's not because they wanted to. It's because they had to sell it. And so it's very rare. I would say probably less than 5% of companies sell, what's the right way to say this? There's actually there's a term in tech that is a little crass, but I think it's safe enough to say. So talking to founders on the West Coast, the term they will ask is, when you're selling your company, did you sell it for FU money? And this is coming from the Bay Area. In a very small fraction of people, the answer is yes. A very small fraction, it's maybe 5%. The rest, the answer is no. The rest is they sold because they had to. So for people that are naive to this, when they see an acquisition, it looks good, it's exciting, and it is good. You were able to get the investors, you were able to get an exit, but it's often not. Selling companies like selling a baby. You never want to sell your baby. But the funny thing with our story is we had an acquisition offer our first year. So DataRobot tried to buy us our first year, and we signed the LOI, and those terms were very different. It was a very aggressive acquisition offer, but we backed out after a few months because we were working with SpaceX, we were working with some very interesting partners. And I think as a first-time founder, you look at your revenue momentum, and it's a very difficult thing to sell your company the first year. Because the first year, you always think that your company is the Facebook, the Meta of your category. It's this naive arrogance. But 3 years later, when we sold it because we had to.
So you're still working with SpaceX?
No, not currently.
Okay.
So, and this is more of a founder strategy. A lot of founders get in trouble courting vanity brands. So us courting SpaceX was a mistake because we are a very small company. So I think we did 7 trips on site. It looked like we were going to contract, and then our champion was laid off. So SpaceX had a behavior where every couple of years they'd lay off 10% of the company. And a lot of times it wasn't merit-based, it was merit plus politics. And so we lost our champion. And so really big deals that you think are going to close, this is something that is common with the founder community. You'll have founders that chase whales, And whales are very difficult to capture when you're smaller companies. You're almost not, you don't have the resources, but also you can't handle the disappointment of losing out on these mega accounts.
So, if a founder listening to this and quite intrigued and not fully convinced, but intrigued, where do they really start?
So, anyone listening to us, if so, our business model currently is we have a few options. So, we can engage very quickly with a client, and we can give them a superhuman algorithm in a few weeks on their data. And we can actually give them that code indefinitely. They pay no license for that. They can keep that forever. They
Explain
don't
the
need it.
journey. Explain the journey a little bit more. They are not trying to build this
Oh,
themselves. Obviously, it doesn't make sense. They want to understand how to leverage this capability. What does that journey actually look like for them?
so if they have a problem they're going after, let's say binary classification, regression, time series, there's a list of problems we support. We can give them a better solution. So if they already have that data set, they understand the problem, we can engage with them, and within a week or two, we can provide them a superhuman algorithm that is better than anything their humans could have built, and they can have that indefinitely. So from our perspective, the relationship can be over. We'll give them that, they can keep that, they can deploy that, they can scale that. But if they want us to then enable them continuously, where they can always invent, because the interesting thing with this is, if you want a better algorithm forever, we can give you a better algorithm forever. So let's say you're looking at an algorithm right now and you really like it. If you want better performance, it's just more compute. You're not asking for more brains. We can literally just run our system on your compute infrastructure, and then you'll be looking at a continuation of better algorithms. So that's our SaaS license. So we have a quick POV that we engage on, but ultimately they have to have those problems defined. So if you have a founder that has not deployed any machine learning applications, if they're early on, they're not a good fit. If you have someone that understands that these particular problems have a meaningful impact for their business, then we should talk. We should understand what they are, because the human approach is your opinions change over time, and my opinion today is the human approach is clumsy. It's comparable to a caveman, and then they fall into the knowledge. The vast majority of data scientists lack the knowledge to even use human known methods effectively, and that's what we're trying to fix.
So, if you could give one advice to a founder or enterprise leader evaluating whether to leverage autonomous algorithms, what would that be?
So I like to take the CFO perspective.
Okay.
So the vast majority of AI efforts globally, they fail at attribution. So I would say, even when I talk to CDAOs, chief data analytics officers, at least 80% of them do not have a good relationship with their CFO. They do not have good attribution. So if I ask, for the sake of argument, let's say you're a typical CDAO, if I ask you, what value are you delivering to your organization? They will typically try to cherry pick that, I had this problem a year ago, I had this, but they don't have a very good story for the overall value that they're adding. And that's why the tenure is so low. That's why I think the number is 14 months. So you're on the chopping block every 14 months, and that is very common in the industry. So from a CFO perspective, so looking at the CFO and CEO, they have some priorities. They have to maximize the value from their data assets in the market. They have to maximize their innovation efficiency, and they have a talent problem. How are they going to hire new talent to adapt to the future? And so that's really the conversation we want to have, is we can address all three. We can, I love this quote. It's not mine. Don't sell software, sell promotions. So looking at the CEO and CFO, that is always on our mind, is we don't want to engage with anyone unless this is going to be a promotion. And it's only going to be a promotion if it addresses these primary concerns. What is the value? Everyone has a talent problem. And what is their rate of efficiency and the level of risk that they have to take? and that's what we're trying to address. So I do teach a course at NYU. It's a AI masterclass for executives, and so really our preference is to have. We really want to talk to the C-suite. So we could talk to a director of data science or like a technophile, but we really want to have the executive conversation because that's where we get a lot of clarity on what are their priorities. But we also get a bigger surface space. We don't want to fight over table scraps. We want to be invited to family dinner. We want to understand all of the data assets that they're dealing with because that's where we can give the best advice.
So Jepson, you built VEOX betting on this shift. 1 year from now, and hopefully we get to talk then, what does the landscape look like for companies that moved versus companies that didn't?
So this, I appreciate that question. It is a huge paradigm shift. Humans have always invented algorithms for general use, and we're moving into a future where algorithms are made for specific use. So you're literally inventing an algorithm for your company, for your data asset in real time. And Eric Schmidt, a lot of people have predicted 2027 as a key year. So you have Eric Schmidt has been talking about superhuman coding. You have AI 2027. You have situational awareness. They're all predicting by the year 2027, you're going to have superhuman programming. And that's one of the things that we're going to start sharing on our social media feed much more regularly. We'll start sharing full source code for superhuman alternatives. And so I think what you're going to see over the next year is something that feels controversial, something that feels impossible will be anxiously accepted because ultimately it comes down to money. The companies that embrace this will make more money than the companies that don't. But there is another theme too. This is unrelated to my company. We have another huge issue, and that is with platforms. So if you spent 10 years building a SaaS platform, you're moving into a world in the next year where someone can build it in a day on Lovable. So this becomes a bigger problem for you. What is your moat? So you spent 10 years building this incredible SaaS product, and when it turns out that some kid can build it in a day on Lovable, that is a huge issue because the build versus buy is no longer compelling. I was buying Salesforce from you because you built it, or I was buying this from you. And so this is going to be confusing for leaders on, I like to say, ultimately it'll come down to your data. So you building this very impressive SaaS offering for me, the time to build that and replicate it is collapsing to zero. And so that's going to be confusing for a lot of your listeners on how do they prioritize platform and how do they prioritize internal innovation? And I don't see their internal innovation competing. So our hope is the dream for me is we would establish a monopoly around innovation.
So good luck to that. So from 1 year from now, if you and I get to talk about again, which I look forward to, what would be the kind of outline that we will discuss? What do you think?
So I've been talking to my team about a year from now, I want to get to 95, 99% code automation. So that would be a year from now, all aspects of the system would be self-improving without us. And it would be hands off. And then the onboarding a new algorithm category would be automated. So right now it's not automated. So if you come to me and you say, I need binary classification with audio, we can add that, but it's a process. We have to go through a process to add that. And so a year from now, my hope would be every algorithm category possible, you could add that yourself based on a curiosity in the morning. And then you'd be looking at your own superhuman alternative, which is kind of strange when you think about publications. Is I think there's an arbitrage over the next 2 years. You publishing something in the AI space is interesting, but 2 years from now, no one will care because it will be your child could sit down in front of the computer and they could ask for a profound breakthrough in computer science and they'd be staring at it. And then they could ask for the IEEE publication and they'd have that as well. And so what does that mean? It's a wild, I think we won the lottery when to be alive. It's kind of a crazy future.
I will look forward to that conversation a year from now with you. And before we close, any final thought?
I think the final thought will be a lot of people are anxious about keeping up, and I think ultimately it's going to come down to passion. So I like to say people are normal, curious, passionate, obsessed, and then purpose. So if you can really embrace these technologies, become passionate, become obsessed, you'll be just fine. If you are obsessed in this space, you will survive the future. But if you are curious, if you're scared, then unfortunately, I don't think the future will be kind because of, we went to school where you could maybe school was hard, we go get a job, and job is relatively easy. We become a domain expert. And I think, unfortunately, we're all on the fast track for the rest of time. And so I think everyone have to consume these technologies as fast as they can.
On that philosophical and optimistic note, Jepson, thank you so much for taking the time to join today. I really enjoyed the conversation. I wish we had more time, but I just can't thank you enough for the time you gave. It was fascinating.
And thank you for the questions. It's a difficult topic, and you did a fantastic job managing these questions, which I appreciate. A lot of people are stuck like a deer in the headlights. They don't understand what we're talking about. You did a fantastic job navigating the chaos.
Thank you, really appreciate it. And people who are listening, all right, if you're listening, what do you think? Drop a comment. We read all the comments, and subscribe for more conversation like this. Next up, Milan Rao on innovation at scale, how to lead global growth by leveraging AI. I'm Subrata Kar, and thanks for listening. Bye for now.